Hello friends, under the theoretical distribution type, we can broadly classify them as discrete and continuous distribution. And under the discrete distribution type, what we are going to see in this video is about binomial distribution. Totally we have two distributions for our syllabus, one is binomial, the other one is Poisson. So this video will help you to understand the concept of binomial distribution. So when is the case that we will have to apply binomial distribution? That is going to be the first and prior question. So when we have the number of trials to be less than 20, that is we have fewer number of objects to be observed for or fewer number of times we do the action for, then we apply a binomial distribution. Then we go for binomial distribution. And when this n is going to be more in number, it moves upper and upper, then you move on to a Poisson distribution. So that can be the first thing by which I can distinguish what distribution to apply, whether a binomial or Poisson. Next, when it comes to binomial distribution, it actually each of the independent actions will follow a Bernoulli trial. What is meant by a Bernoulli trial? You have only two outcomes out of it. So what is it is either you have something called as a success or you have something called as a failure. There is nothing in between this. So quantities of such kind where you have just two outcomes, either a success or a failure, will be now applied for a binomial distribution. Say for example, you're going to have the case of a match being played in a football. So at the end, there can be success, there can be failure, and apart from that, there can also be something called as a draw. So you have three options or three outcomes over here. So you can have a success, a failure, or it can be a draw. In which case, the football match cannot be termed to be one that can be solved using a binomial distribution because it has a third option. But rather, when you're going to start a game, maybe you can say that you're starting a game by tossing a coin and you're choosing which team will perform first, tossing a coin. So what is going to be tossing a coin resulting in? It will either be a head or it will be a tail. So if the option is going to be chosen as the team chooses head and it gets head, then you term it as success. If it gets tail, then you term it as a failure. So when you are tossing a coin, then this will follow a binomial distribution. So keep in mind, whenever the number of trials are fewer in number and you know for sure that there are going to be exactly two outcomes out of the action and not more than that, so for sure you have something called as a success and failure, then such distribution can be best suited to be applied using a binomial. Next comes the probability mass function for a binomial distribution. So what is going to be the probability mass function? So this now gives me probability mass function is probability that x, capital X, the random variable, takes the value small x. So this is given as n c x p power x q power n minus x. So this is defined as the formula for your binomial distribution. So we can state this as probability that x takes the value x is given as ncx p power x and q power n minus x. Now this is just a formula, but we need to specify where this formula is going to be valid, unless then it is not going to be of any use to us. So the validity of this formula is for x varying between 0, 1, 2 up to the finite number of times the action is being repeated, which is going to be n. So be very careful about it. You can perform the action for 0, 1, 2 up to n. Now coming to the terminologies over here or the quantities involved in this formula. Already we know about n. What does n stand for? N stands for the number of trials. So next comes the quantity called as P. What does P termed as? P is termed as the probability of success. So if getting ahead is termed as success, then when you toss a coin, out of the two options, getting head is success, then your P will be equal to half. So what does the second letter over here represent? Q. Q is going to be the probability of failure. So when you are measuring success by P, the failure is measured by Q. And how you can relate both of them? We know that success plus failure is totally equal to the probability 1. Hence, we can relate these two quantities by P plus Q equal to 1. So if one of them is known, the other one can be estimated, like Q can be estimated as 1 minus P, or you can estimate P to be equal to 1 minus Q. So one of the quantity is known, the other one can be estimated using this relationship. Now to define this binomial, I need a minimum of 2 of the quantity. One is n for sure, the other one is going to be P. If P is known, automatically Q can be derived from 1 plus 1 minus P is equal to Q. So these two quantities are called as the parameters of the binomial distribution. Symbolically, we write it as X follows binomial distribution with parameter n comma p. X follows binomial distribution with n comma p. Now the next thing what we require is going to be this NCX computation. How to compute this NCX? So when we have a calculator, we have elements or the letters, buttons which are going to be white, yellow and pink in color. Now on top of this division button, you can find something called as NCR. So please note, on top of this division we have this NCR, but this is yellow in color. To activate this yellow buttons or yellow actions, what we need to do is, on top of the calculator you have something called as shift button. So after pressing the shift button, if you are going to press this button, then your NCR can be activated. Like say suppose you want 10C2. So first press 10 in your calculator, press this shift button, then press this division button. You can see a C that appears on your screen, and followed by it you need a 2. So press 2 and then press equal to, and next your answer will be displayed over here. Now you can try NC2 to be equal to, check if you're getting it to be equal to 45, 10C2. So this is how you can use effectively your calculator to estimate the data for your binomial distribution. Already we have loaded a video for effective use of calculator. So you can directly key in the expression for your binomial and then get the data one after the other by just changing the quantities of x or the variable x for the requirement. Now we'll quickly see how to estimate a probability for any given data. So when we want probability of x as 2 and our n is going to be equal to 10, say we have probability P of success is going to be 0.3 and Q is going to be equal to 0.7. We need to take care that P plus Q is always equal to 1. So how to go about it? So this is nothing but 10C2 0.3 power 2 0.7 power 10 minus 2. So this makes it as 10C2 0.3 power 2 0.7 power 10 minus 2 makes it as A. So when you add these total powers over here on top, you must always be getting your n back. So make sure you are going to check on these quantities, and to key in the data and to get the answer, you can just take the help of the video which has been loaded prior to this. Now the most frequently used statistical averages for the computation of the binomial distribution. Now this statistical averages what we will be using for the binomial distribution is first given by mean of a binomial distribution is given by the formula n times of p. Variance of a binomial distribution is given by the formula n into p into q. Next comes the standard deviation of the data, which is given by root over variance. This is going to be a general formula. Standard deviation is always expressed as root over variance, in which case now this will be expressed as root over n p q. So these statistical averages will make our work much simpler, and then estimation may become much easier for us. Now we will quickly see how this can be put into use for a problem. Say suppose the mean of a binomial distribution is going to be equal to 4 and variance is going to be equal to 4 by 3 for the binomial distribution. Find the parameters of the binomial distribution. So what are the parameters of the binomial distribution? They are my n and p. How I can estimate this n and p from these two given datas? So what I know about mean of the binomial distribution is given as np, and this has been marked as 4 for me in the given data. What is going to be the variance of the binomial distribution? This is npq, and no, this has been given as 4 by 3 for me. The best thing is you can just go put it over here and then find the value of q. So in which case 4 times of q is equal to 4 by 3. 4 can be cancelled on both sides, so this gives me q equal to 1 by 3. This is one way of approaching. The second way of approaching is divide one by the other. Divide np by npq. So what will happen? It is 4 divided by 4 by 3. So the 3 will go to the numerator. 4 can be cancelled off. np and np can be cancelled off. This gives me 1 by q is equal to 3, or the same can be reciprocated for get q is equal to 1 by 3. So once obtained the value of q as 1 by 3, the next thing is using this I can get what is going to be my p. What is the relationship that connects p and q? We know that p plus q is always equal to 1. So my p will be 1 minus q. So it is 1 minus 1 by 3. What is 1 minus 1 by 3? Take 3 as LCM. 3 minus 1. So it is 2 by 3. So the value of p is 2 by 3. Now I have got my p. The last thing to be estimated is going to be my n. How to get the value of n? I know that np is equal to 4, and I have just now obtained the value of p as 2 by 3. So now n times of 2 by 3 is equal to 4. Now this can be cancelled off. So how many times? It goes 2 times. Cross multiply this 3 to the opposite side. So n is equal to 2 into 3. So n is obtained as 6. So we have obtained the parameters of the binomial distribution. So for this problem, it's such that the random variable x follows binomial distribution with number of trials n to be equal to 6 and probability of success to be equal to 2 by 3. This is how you can estimate the unknown quantities from the given data.